Hi guys, welcome to Pagapayu channel. We have already posted few videos on hypothesis testing. We have already shown you how to conduct t-test, which are one sample t-test and two sample t-test. In two sample t-test, we have compared samples from two different groups. In case if we are getting samples from more than two groups, then we have to use ANOVA test, which is known as analysis of variance. If you don't know about t-test, the link is available in description. Please go and watch our past videos. So here, this ANOVA test is used to compare more than two samples or samples from more than two groups. It can be three, it can be four, or any number of groups. So here, the null hypothesis is the sample means of all groups are almost equal. So which means there is no significant difference between groups. On the other side, the alternate hypothesis talks about at least one pair means are unequal, or at least one sample mean is different from the rest of the samples, whatever the way you can say. There are different types of ANOVA tests: one-way test, two-way test, then n-way test. So here the 1, 2 denotes the number of factors which we are going to consider in our analysis. So n-way test is also known as MANOVA, which means multiple factors test. The factor is an independent variable. So which we will talk further about this. So here the assumption in ANOVA test are the observations, whatever this, which means the samples which we are collecting should be independent and should be random for the defined factor levels. The data, whatever you are collecting for each factor level, is normally distributed. So whatever the case should be independent. The independent of the sample cases, whatever we are selecting, should be independent from each other. The next thing is homogeneity of variances. Whatever the groups or the samples from which we are, the 3 or 4 samples what we are collecting, the variances among the group should be approximately equal. These are 4 assumptions. If any sample groups which meet these assumptions, then we can conduct ANOVA test. Now we will explain you with the business case. So here there is a sports manufacturing company. They are manufacturing golf balls using 4 different methods or design, you can say. So they have manufactured 10 balls with each design and they have brought it to a golf course for the testing. So the balls were hit randomly, and at the same time they have hit so that the environmental conditions and everything remain same, and the results, which is the distance travel of all 4 designs, which is totally around 40 balls, which is 10 balls of each design. There are 4 designs, so 4 into 10, which is 40 balls. Results, which is the distance traveled in yards, has been taken and it has been stored in a CSV file. So the level of significance, these and all we have talked earlier in our past videos. So here with 0.05 level of significance, is there evidence of a difference in the mean distance traveled by golf balls with different design? So we have to ascertain whether all 4 designed golf balls are traveling at the same distance, or is there any variation, which is the mean travel distance, you can say. So I am having the file in my Google Drive. So I am mounting the Google Drive first. So for reading the CSV file, I need pandas package. So I'm importing pandas package as PD. Then I'm extracting or reading the CSV file from the Google Drive. So from the drive, I have got, this is the data. So you can see the distance traveled in yards of each design is captured. First, the design 1 is captured, then design 2, similarly design 3, design 4, everything is captured in that file. So I'm just taking a summary using the code golf dot describe goals is the data frame golf. So this is, there are 40 entries, so that's why I count. So the minimum maximum values and the mean values, which is around 220 yards, is the mean. So which is talking about all 4 design, but I am creating a summary for each design. So if I'm considering design 1, here the mean distance is 206 only, which is less than 220. When we go to design 2, here the mean is 218.5. Then design 3, 219.5. And then design 4, which is 228.62. So you can see that the mean between the groups are different. Maybe 226 is the mean, sorry. In design 3 to 26.5, the nearby is third and fourth group are nearby based on the mean data. But whether statistically, whether they are same or not, that's what we are going to describe using ANOVA method. So I am going to show some visualization plots for checking the normality of each factor. Here the factor is nothing but the distance traveled by golf ball is the factor which we are going to compare. So I'm importing Seaborn package. First I am coming up with the box plot. You can see this is very quite clear. The distance traveled by design 1 is much more lower. Then comes design 2, design 3 and design 4 are almost nearby. So next, for confirming the normality further, we are going to draw histogram with normality density line. So here you can see for each design, there is a separate plot has been shown over here. So you can see it is completely right skewed. First design is, the second design is normally distributed at the center. So this is third design is also over, okay. And the fourth design is left skewed. So we can say these are normally distributed data. The next thing is we talked about homogeneity of variances. So which means the variances among the group should be almost equal. For that, we can do Levene's test. So this test is used to check the homogeneity of variances. At the end of the Levene's test, if the p-value is greater than 0.05, then we can confirm that the variances between groups are equal. So for that, I'm importing scipy.stats package with the name stats. So here there are 4 different groups. So in golf data frame, we have all the 4 designs values in a single data frame. So now I am just splitting it for conducting the Levene's test. So the design one data frame is created considering only the data related to design one. Similarly, design two capturing the data related to design two, design three, design four. So 4 data frames are created. So here further what I have did is I have taken only the values, because if you see, just I will show you, if you see design one, this column design one, design one, design one, so which is of no use, because in Levene's test we have to provide only the values, and that too it has to be single dimensional. So what we are doing is we are selecting only this particular column. So I'm giving the name design one underscore R. R means revised data. So I'm selecting only this particular column. So now if you see design one underscore R, see, I'm having only the distance value, so which is related to design one. And another thing is which we have to check is how many dimensions are there, which you can check with the code design one underscore R dot shape. So here you can see it is 2-dimensional. So which means Levene's test will throw you error. So how to conduct or convert this data frame or matrix, you can say, in 2-dimensional to single dimensional, which means you can flatten it. So I'm creating 4 different lists, D1, D2, D3, D4. I'm converting into a NumPy array, and then I'm flattening it. So I'm converting first to array, then using flatten code, I am converting this into a single array. So just you can see, in case if I am not flattening the first data frame, I'm just converting into an array. So here you can see D1 dot shape, what I'm getting is again 2-dimensional. So here for conducting the Levene's test, it is simple. Stats is the name of the package, scipy.stats. Levene is the test name. So there are 4 different groups. So D1, D2, D3. So each group refers to each design group. So if I am conducting the test, since I fail to flatten this, Levene's test is showing an error. Samples must be 1-dimensional. So I am flattening this to single dimension. So now I am done. So you can see there is only 1 dimension. So which is 10 rows. So if I conduct the Levene's test now, you can see I am getting the results. Here the p-value is greater than 0.05, which, as we said earlier, you can conclude that the variances among the group or between the groups are equal. So which means you can conduct ANOVA test. It is meeting the assumptions what is required to conduct the ANOVA test. So now we will talk about one-way ANOVA test. Here there is only one factor between the group, which is the distance traveled by golf ball. So here I am taking only the distance. So which means it's very simple. the distance mean of design 1, the mean of design 2, mean of design 3, mean of design 4 should be equal in case of null hypothesis. And when it comes to alternate hypothesis, at least one pair, there should be difference. So this is what we have to prove in this ANOVA test. So now we have to write the code. So first we have to import stats model.api as SM. So we are importing stats models.api, which is one package. And then from stats model.formula.api, we are importing this OLS command. So we are building a model. OLS design is a, distance is a function of design, because there are 4 designs. So which depends on the distances depends on this design. So first I am defining the function, and then I am going to the data. Data is the goal, is the data frame file, and then I am creating a fit. Then AOV table, which is analysis or analysis of variance table or ANOVA table, you can say, which is SM, is the package name stats.ANOVA_LM. Then model is already we have created a fit. So we have named it as model, then comma type 2, TYP is equal to 2. Then we have to print the ANOVA table. So execute this code, you will get a result. So here, this is the p-value, which is e⁻−13, which means very, very low, 0.000, which is 12 times 0, so which is very less than 0.05, which means you can reject null hypothesis. And that means there is difference between groups, but from the ANOVA test, you can't conclude which group is making a difference, right? So here it is saying that, yes, it is making a difference, but it is not talking about whether design 1 is making a difference, design 2 is making a difference, or which pair is making the difference. So we have no idea. For that, we have to conduct ad hoc analysis, or with the support of TukeyHSD test. So here the codes is very simple. So here what we are going to do is multiple comparisons, of which there are multiple groups. Here there are 4 groups. So what we are going to do is we are creating a multiple comparison, which is known as MC. So SM is the package, stats.api is the package which we have already imported. From that package, sm.stats.multi-comparison, and there are 2. One is the factor variable, and another one is which is the design, which is affecting this factor. So here the distance and then design, both things X and Y, you can say, you have to mention here. And first create the model or multiple comparison, then create the results using TukeyHSD test. So TukeyHSD is the code mc.TukeyHSD. Then you print the result. So here, once you execute, so you can easily understand whether you can decide based on the p-value, which here group to group comparison is shown. In TukeyHSD, this is what is important. So once it talks that the groups are different, then you have to, if it is saying that the null hypothesis you can't able to reject it, which means it is going to say that all the groups are similar, then you no need to conduct the TukeyHSD test. But if it says that the null hypothesis is rejected and there is at least one pair is different, then you should conduct this test. Then only you can understand which group is different. So here you have to reject in all the cases, which mean design 1 and 2, design 2, 1 and 3, design 1 and 4, these are not equal. So here the mean values, statistically, they are not equal, even design 2. Only in case of design 3 and 4, the value is 0.7, which is higher than 0.05. And here also you can see false. So which means you can say that the pair 3 and 4 mean is equal. But beyond that, all other pairs mean are different. So I think you have understood this concept very well. So we will talk about the other types of ANOVA tests in our next video. If you like this video, please give a thumbs up. Kindly share with your friends and do subscribe our channel. Thanks for watching. Bye-bye.